All right, alkynes, right? The rule for alkanes, branches are the most important because that's all that we have. Alkenes, the double bond becomes most important. Now with alkynes, that becomes the most important. So we want to count this chain in a way that gets us to the triple bond with the lowest number possible. So we're going to count from the left, 1, 2, 3. That gets us to the triple bond. If I counted from the right, it would be 1, 2, 3, 4, 5, 6. So we want to count from the left. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we've got a 9 carbon. So 9 would be nonane, right? We have a triple bond. We've got a carbon-carbon triple bond. So that would be the YNE we have to add. So that would make this none 3-ine, right? I've got 9 carbons. On those 9 carbons, on the 3rd carbon, my triple bond starts. And then the last thing we need to incorporate are our branches, right? So on the 2nd carbon, I have a methyl group. And on the 5th carbon, I have a methyl group. So we'd add those two in to say 2, 5, dimethyl, none 3-ine. There's no cis or trans. There's nothing else. We've got all the branches accounted for. The biggest mistake in naming alkynes, and I'm not sure where this comes from, is sometimes people will drop a carbon. They like count this as 1 carbon, even though there's 2 carbons in that carbon-carbon triple bond. This is honestly the biggest mistake I see with these structures. Yes, Mona? Cis or trans is only with carbon-carbon double bonds because we have to have 2 substituents where we have that spatial arrangement where it's different, right? So we could have a cis double bond right, where those carbons are on the same side, or we could have a trans double bond where those carbons are on opposite sides. So we have to have 2 different substituents because here, if I change this methyl group with this hydrogen, that changes the structure. Here with an alkyne, we have one, there's really no orientation around that that's going to move, right? We have 1 substituent here, 1 substituent here, so there's no real spatial arrangement there. Yeah. Correct. You apply a dimethyl anytime you have 2 methyls. If we had 3 methyls, this would be trimethyl. It doesn't matter if they were on the same carbon or different carbons. So if they were both right here, we would say 2,2-dimethyl none 3-ine, right? Doesn't matter if they're on the same carbon or not. We need, and I know it sounds redundant because we said there's one on the 2nd carbon, there's one on the 5th carbon. So you would think 2,5-methyl is enough, but we incorporate the di indicating that there are 2 methyl groups total in that structure. All right, now Fiona, yeah.